And so here's the easiest section of the whole module. We're investigating symmetry. How do you determine whether a figure has line symmetry or rotational symmetry? Very simple stuff. Let's take a look. If you go to the very top over here, what is a symmetry? A symmetry is basically explained this way. If I have a shape, like a heart, okay, and basically I can draw a line over here, and if I were to fold the paper in half, and this side goes right on top of that side, this is called, this line is called the line of symmetry, okay? And then, what is this heart? Okay, this heart is symmetric to this line of symmetry, okay? And that's pretty much what it says over here when it maps the figure onto itself. I was just talking about the heart, the line of symmetry. I told you what that is. Also, we call it the line of reflection. And so they give you an example. You have a shape here, you fold it this way, and it goes on top of each other. So this one has a line of symmetry, right? And so if you look at the example over here, they give you many examples. Like this one has no line of symmetry. And what about this shape over here? This one has two lines of symmetry because you can fold it like this. You can also fold it like that, okay? What about this triangle over here? You only have one line of symmetry because you can only fold it one way. If you try and like fold it this way, it doesn't really work. You gotta actually try it yourself, but you will be able to see. Then you have some examples. How many lines of symmetry do you think there's going to be for this one? Well, you know, if I were to like fold the paper in half this way, I think it would overlap with each other. But if I were to like fold it this way or that way, it wouldn't work. So there's only one, okay? So then of course you can select your answer. And if you check your answer, they tell you it's correct. And then just in case you don't know, they tell you to click on view and then it tells you, right? So you can do the same thing with all these other shapes. The important thing is, look, over here, the letter S, there's no way you can cut it off and it would overlap with each other. No way. You can't cut it this way. You can't cut it that way. So that's why there's no line of symmetry for this one. But this one, I got this one wrong. The letter L, I'm like, okay, there cannot be a line of symmetry. But actually, if you look at the answer, if you were to fold it like this, then this side will overlap to that side. So the answer is actually 1 for this one. And you know, it's always cool to solve these problems. And then if you click on this, of course, it shows you. And I'm like, oh no, that's why I got it wrong. So again, it's a very easy section. You can just use common sense. So we were just talking about the line of symmetry. Sometimes we have rotational symmetry, okay? The word is right here, rotational symmetry, which means like we have a shape like the heart. Again, I need to first learn to draw the heart so that it overlaps itself. So we were talking about the line of symmetry, but we can also have a rotational symmetry. What that means is I have a point right here and then I turn this around, right? I turn it around and then it maps onto itself. As you can see, obviously with the heart, even if you were to like turn the heart around, there's no way it's gonna map itself onto itself. So there's no rotational symmetry in this shape, heart, okay? We only have a line of symmetry on the heart. Okay, so then they give you some examples over here. As you can see with the star, okay, of course you also have a line of symmetry. You can draw a line like this, and then if you were to fold the paper in half that way, it would map onto itself, okay? But it also has a rotational symmetry, meaning you start from here, and then if you were to rotate, turn the star that way by 72 degrees, it would come out the same shape like that. Okay, so it's really important. Some shapes have both line and rotational symmetry, and some shapes they have none. Some shapes only have rotational symmetry. Some shapes only have a line of symmetry. Okay, so let's see. So they give you some examples. This triangle over here, of course, you can fold it in half like this, or like that, or like that. There's 3 lines of symmetry in this triangle, but also you can rotate it. And you can rotate it like not just once, but more than once to get to the same shape, right? So here's the triangle, and then you rotate it, okay, this way. And then what happens? That's 120 degrees. You have to start from here and turn it by 120 degrees, and it's the same shape. But you can turn it one more time, and by 240 degrees, and it will be same again. All right, so same thing over here. You can rotate it, but see, here's the key thing. You gotta figure out by how much did you rotate it, how many degrees, right? So that's something hopefully you'll be able to figure out. Okay? And so basically, usually if you think that you have to turn it around like that, then it's 180 degrees. But you know what? Let's try and work on this in the classroom with hands-on activities so it'll be easier for you to understand. But that is pretty much the whole lesson. Okay? And here's the main thing that I kept on talking about. A figure can have a line symmetry, rotational symmetry, or both types of symmetry, or no symmetry. And so, of course, any test questions from this section is going to ask you that, right? Does it have a line symmetry, rotational symmetry, both types, or none? And then if there is a line symmetry, how many? If there's a rotational symmetry, how many degrees can you rotate it by? And so very simple stuff. Everything else you pretty much have to solve it on your own and figure it out. As you can see, Miss Choi studied before teaching. All right, and of course, watch Mr. Berger. That really helps out a lot. Your homework questions are very similar, but I told you the most important part is what? Evaluate, because the evaluate section is where I come up with most of my test items, right? Okay, so happy learning. See you in the classroom.